Good morning. This is Ms. Billerbeck, and we're going to talk about 10.2, the converse of the Pythagorean theorem. And what converse means, it means the opposite. So if this is so, then so is this. Do you get that? So if A equals B, then we know B equals A. That's called a converse. So what we just studied is a squared plus b squared equals c squared for right triangles. But we know that also the converse would be true. For any triangle with sides A, B, and C is the longest, then a squared plus b squared equals c squared if it's a right triangle. So we can actually use our numbers to determine if it's a right triangle without even knowing angle C is 90 degrees. All right, let's see how that works. All right, so if we have a triangle, GHK, and G is 89 centimeters, H is 38 centimeters, and K is 80 centimeters. First, we determine which one's the longest. Well, that's G. So we're going to set the problem up. H squared plus K squared equals G squared. If that's true, we have a right triangle. So let's see, we have 38 squared plus 80 squared. And we want to know, does that equal 89 squared? Well, that is a very good question. So let's find that out. So 38 squared is 144, or 1444, excuse me. 80 squared is 6400. Oops. There we go. And 89 squared is 7921. Well, that does not look like they're going to be equal. So when we add this together, we have 44, and then we have 8, 7, and that does not equal 7921. Okay, so we have determined that this is not a right triangle. And I'm using the triangle symbol for the word triangle. All right, so there we have it. So now let's try this one. So we have 17, 144, and 145. So that would mean that 17 squared plus 144 squared should equal 145 squared. Well, let's see. So this is 289. And let's see what 144 squared is. Whew, that's 20,736. And does that equal 145 squared? That's 21,025. Okay, so when we add these together, okay, we get 2125 equals 2125. So we have, so triangle XYZ is a right triangle. All right, let's look at another problem. So if we're given triangle PQS, and we want to find PR. So PR is right here, and we're given PQS. Okay, so we don't know what we're dealing with here yet. So let's take a look what we can find. So we have an outside line here, and we have a line here, and we have 74 here, the square root of 74. Now we can figure out, well, the square root of 74, it's between the square root of 64 and the square root of 81. So the square root of 64 is 8. And the square root of 81 is 9. So that's around maybe 8.5 if we were estimating. Okay, so then that means that this side length is 5 and this side length is 7. So clearly 74, square root of 74, is the hypotenuse. So we're going to write 5 squared plus 3 plus 4 squared should equal the square root of 74 squared. So 5 squared is 25, and this is 7 squared, which is 49, equals, and the square root of the square of a square root is just what's inside the square root, so that's just 74. So now we add this together and we see, oh, well, that is 74. So there we have it. 74 equals 74. So now we know that the measure of angle Q equals 90 degrees. So we have a right triangle. So now we can find PR. So we have PR is 5 squared plus this 3 squared should equal PR squared. All right, we can rewrite this as PR equals the square root of 5 squared plus 3 squared. So PR equals the square root of 25 plus 9, which equals the square root of 34. All right, and square root of 34 is just the square root of 34. So that means that PR, we can say PR equals the square root of 34. And we didn't get any units, so we'll just put U for units because it is a length, so it does have some sort of unit. All right, so that's it for section 10.2, and next we will talk about how we apply the Pythagorean theorem. Have a wonderful day. Bye-bye.